Many times students come to me and tell me that they get scared whenever they come across scatterplot diagrams. And I tell them that this topic is not new. This is something that you've already covered. A scatterplot is basically a graph with points on it. The only difference is that points are scattered. A scatter plot can look like this. It is basically a straight line. A scatter plot can also look like this. In this scenario, we are looking at a quadratic function. A scatter plot can also look like this. In this scenario, it's an exponential function. So all these graphs are very similar to what we have already done. If you have a straight line scatter plot, what are the questions that you can come across? The examiner can ask you the equation of the line or the gradient of the line. These are the questions that you can come across. So don't worry about these questions. They are exactly similar to what you have already done before. Let me show you the various types of scatterplot diagrams that you can come across. Let's have a look at this scatterplot. The scatterplot above displays the percentage P of paper consumed in the United States that has been recycled from 1990 to 2012, where T represents years since 1990. So this is T and it represents years since 1990. Which of the following equations best models the relationship between years since 1990 and the percent of consumed paper that has been recycled? On the x-axis we have the years since 1990 and on the y-axis we have percent of consumed paper recycled. Now you can see we are basically looking at a straight line. Draw a straight line like this. It's not a nice line. Let me redraw it. So a straight line like this. You understand the point. It should have like half of the points above and half of the points below. If I have to draw it again, I think I can draw a better line, something like this. Yeah, this is better. So half of the points should be above and half of the points should be below the line. This is called the best fit line. Best fit line. Remember this. So let's form the equation, and you know the equation is y equals mx plus b. We have already studied this. See, so this is not different. And you can see the y-intercept is basically 35. So the y-intercept is 35 in all the options. Now you need to find your m, the gradient. Now take 2 points and find the gradient. The tip over here is to take points at maximum distance. So when you take 2 points which are far apart, you will reduce the error. This is a very important point. And those points should be easily obtainable. So I'll take 1 point, which is this. So let's say 0, 35 is our 1 point and another point somewhere here. Let's say 22 and 65. Yeah, this is a good point. The second point is 22, 65. Now we have got our 2 points. Just take out the gradient and we will have your answer. Okay, so gradient is y2 minus y1 over x2 minus x1, which is 65 minus 35, y2 minus y1 over x2 minus x1. We are left with 30 divided by 22. You can use the calculator. The answer that you get is 1.3. So you are getting an exact answer. You know option choice B has this gradient. It's the only option which has got this gradient. So that's our answer. Very simple. And if you took some other points, you would have gotten, let's say 1.2 or 1.4. Even then you would choose this answer because that's the closest option. Next question. Sarah monitored gas prices at a local gas station throughout 2014. Okay. The scatter plot above shows the price G in dollars for 1 gallon of gasoline on various days of the year, where D represents days since January 1st, 2014. So on the x-axis, you can see we have our D, days of the year, and on the y-axis, we have price per gallon in dollars. Okay. A function that models the data is shown on the graph. Which of the following best approximates the price for 1 gallon of gasoline on September 12, 2014, the 255th day of the year? So we need to look at the x-axis because the days are on this axis, and 255th is basically this point between 240 and 270. This is 255th day. Draw a dotted line, or let me draw a straight line. Just hold on. So this is the line we are looking at, and see this corresponds to which value of y? it corresponds to this value of y. So this is basically our answer. So on the 255th day of the year, that is September 12, 2014, the price of 1 gallon of gasoline is $3.5. Very simple. The answer is option choice D. Another interesting question. During the 2014 and 15 season, a statistician collected data on a professional sports team. The scatter plot above shows his findings for the average minutes played per game and the average points scored per game for each player on the team. Which of the following equations best relates minutes played per game X and points scored per game P for players on this team? Another tip that you should remember is these questions will always ask you for the best equation or an approximate equation. If the question or an option choice has this word exactly, you can definitely cut out that option. It's definitely a wrong option because every student will have a different line of best fit. Some can draw like this, some can draw like this, very close lines. So you can never say that this is the exact value. So please remember that. Okay, so we can clearly see that we have a straight line. And if I draw a straight line, I will have something like this. See? This is the line of best fit. Now we just need to calculate the equation y equals mx plus b. There's very important hint that you have, that is b. You can see that b is negative. The line is going like this. So the y-intercept is basically negative. So just look at the options and eliminate the options where y-intercept is positive. You can definitely eliminate option choice B and you can eliminate option choice D. Now you need to calculate the gradient, which is m. You know the drill. Take 2 points which are maximum distance apart and make sure that they are on the line as well. So one point that is easily obtainable is this one. Let's say 3, 0, and the other point is, let's say this one. I can easily see this point, which is 33, let's say 15, although it's a little below 15, but that's fine. 33, 15. Okay, let's find out the gradient. We have y2 minus y1 over x2 minus x1, which is 33 minus 3. So the answer is 15 over 30, which is 1 by 2, which is basically 0.5. So definitely A is not the correct answer. We are left with option choice C. That's the gradient 0.5. There you go. And the equation basically looks something like this. Y equals 0.5x minus 2. You don't have to calculate the y-intercept because we can clearly see that it's negative. This is where you save time. Next question. The scatter plot drawn above depicts the price of 1 gallon of gasoline in the United States from 1980 to 2008. The graph of a quadratic model, it's a quadratic model that fits this data, has a vertex at 17.24, 1.33. What does the vertex tell us about the US gas prices? Let's first evaluate this scatter plot. Price of gasoline in US from 1980 to 2008. On the x-axis we have the timeline, years since 1980. So this basically represents 5 years is basically 1985. Please be very careful. I've seen that students don't spend time in evaluating the axis and the units. Very important. So 10 years is basically 1990. This is basically 1995. This is 2000 and so on. On the y-axis, we have price of 1 gallon of gasoline in US dollars. Okay. So the best fit graph should look something like this. This is what we are looking at. Yes. So let's have a look at the vertex now. So the vertex, let's say, is this value. Let's say this is our vertex and it is 17.24, 1.33. So 17.24 is basically the x-axis. It is years since 1990. So you can say in approximately 17 plus 1980 is 1997. So in approximately 1997, the price of 1 gallon of gasoline in the United States is 1.33. This is what the graph is telling us. Now let's read the option choices. In the year 1997, the price for 1 gallon of gasoline reached its exact maximum value. Just stop here. I told you whenever you come across these words in scatter plots, they are definitely wrong. Eliminate these option choices because it's a scatter plot. We can't give an exact value. It's wrong. In the year 1997, the price for 1 gallon of gasoline reached its exact, again option choice B is also wrong. In approximately the year 1997, the price for 1 gallon of gasoline reached its approximate maximum value. No, it's a U-shaped graph. It's a minimum value. It's a minimum value. The graph is upward open. Please be careful. In approximately the year 1997, the price for 1 gallon of gasoline reached its approximate minimum value of $1.33. D is our answer. Next question. The scatter plot above shows the number of moose M estimated to be living in Minnesota from 2005 to 2012. To be very honest, without even reading the question, you can see that it's a straight line which has a negative slope. It is a decreasing function. I haven't read the question, but this is something that I can see. Now let's complete the question. Which of the following equations best models the population of moose in Minnesota during this time period, where T represents the years since 2005? Okay, so we have our best fit line which looks something like this. Let's say this is our function, something like this. Yeah, couple of points above, couple of points down. So this is the line we're looking at. The first thing is M is less than 0, M is negative, and somewhere the y-intercept should be between 8,000 and 9,000. So this is something that I'm guessing. So let's now eliminate some of the options. Let's have a look at the gradient first. If the gradient is positive, we will straight away eliminate that option. Over here, the gradient is positive. This can't be the option. The gradient is positive. This can't be our option. So now we are left with option choice A and B. The gradient is negative. This is fine. The gradient is negative. Now let's have a look at the y-intercepts. In option choice A, the y-intercept is 8,593, which is in our range between 8 and 9,000. In option choice B, the y-intercept is 10,000. No, this can't be the right option, because if 10,000 is somewhere, 1, 2, this is basically 10,000. No, we can't have our y-intercept here. That will be a wrong line. And if you get confused, just take a couple of points and calculate y and m. You will get the equation, but you need to be intelligent. You can definitely save time here. So I won't do the calculation because I know A is the right answer. Very simple.